Hello friends, welcome back to our channel. So today we'll see one more concept in our computer networks, that is TCP Timer Management. So in our previous session we have seen a lot of concepts in TCP protocol, that is TCP service model, TCP states we have seen, and also TCP header, TCP segment, etc, etc. So today we'll see the timer management in TCP protocol. So TCP timer management. So what it means? So here the name itself indicates a timer, means the TCP will be using certain amount of time to perform any action, or before performing any action. Before performing any kind of action. Okay, any kind of action. So what type of action it may take, right? So action means it can detect the lost packets. It can detect lost packets, and it can retransmit the packets. Similarly, connection. Okay, so avoid or identify the dead connection. We can simply say identify or detect dead connection. Okay, so to avoid waiting time, continuous waiting time, and etc. So all these kind of actions, before doing all these kind of actions, some certain amount of time it will spend some time, which is with the help of timers. So here we will be using, the TCP is using different timers in order to perform all these actions. Okay, so mainly there are 4 timers the TCP will be using. The first one is a retransmit timer, persistent timer, keep alive timer, time wait timer. So here the retransmit timer will be identifying the lost packets and also retransmit the packets. Similarly, persistent timer, it will avoid the waiting time. That means it will avoid the deadlock situations. Keep alive time will be identifying the dead connections. And finally, the time wait timer will be used to close the connection properly. Okay, so we'll see one by one. So first, let us start with the retransmit timer. So we know that if the data, or that means if any packet is lost, automatically the packet should be retransmitted. So when it should be retransmitted? So initially there will be some timestamp. Whenever the timestamp expires, immediately that implies the packet has been lost and that the same packet will be retransmitted. But in that case there will be a lot of waiting time. So to avoid that one, so what happens means, when the packet, so I'll write the steps. So sender sent the data, sender sent a packet and wait for acknowledgement. Immediately TCP starts the timer, starts this retransmit timer. So here 2 cases will be done. If acknowledgement received, before timer expires, then timer will stop. Timer will be stopped because the receiver, I mean the sender, have received the acknowledgement from the receiver. And the second case, if acknowledgement not received, not between, before timer expires, what happens? Then retransmission will be done. Okay, so if the acknowledgement was not received before the timer expires, that implies, that will tell the sender that the packet has been lost. So immediately the retransmission will be done. So this particular retransmission timer is used to detect the lost packets before, I mean in this case, second case, not received before time expires, automatically it means the packet has been lost and automatically it will retransmit the packet. Next, hope you understood this retransmit timer. Next, persistent timer. The next one is a persistent timer. So, for example, let us take a sender and here it is a receiver. So, sender keep on sending the packets. Okay, keep on sending the packets, and at one moment, receiver sends a packet with a message buffer full. Okay, buffer full. Until the receiver sends a buffer full message, the sender will be keep on sending the packets to the receiver. Okay, so here I will write sending packets, send packets, right? Buffer full. Then what happens? The sender will stop sending the packets. Sender will stop sending the packets, and after some time, so this buffer is empty. Buffer is empty. Okay, so this particular thing called as a zero window. That means there is no space to accommodate the packets into the window. So after some time, buffer is empty. And it will send a message to the sender. So I am ready. So I'll write here. So for example, after some time, buffer becomes empty. So what happens if it is empty? It will send some message, I am ready to accept the packets. But unfortunately, it was disconnected. That means this packet has been lost. Okay, this packet has been lost. So whatever the message the receiver was sending, it was not received by the sender, received to the sender. So sender will be keep on waiting for the update message, and receiver will be waiting for the packets, waiting for packets, waiting for update message. So update message was already packet lost, right? So this is called as a deadlock. This is called as a deadlock situation. So in order to close this deadlock, avoid this deadlock, that's a waiting time, so this persistent timer will be used. And after, I mean whenever the sender starts sending the packets, and whenever the buffer becomes full, automatically this timer will be started, and after this time the sender will be sending. So here the sender sends a probe packet to receiver. What is this probe packet? This implies, shall I send packets? Simply this message will be sent to the receiver. Okay, so the receiver will respond and immediately the packets will be again start sharing between the sender and receiver. Okay, hope you understood. So here there is a deadlock situation. In such case, this persistent timer will be on, and after this persistent timer closed, that means expires, immediately the sender will send some probe packet to the receiver mentioning, shall I send the packets? So if the receiver is ready, automatically it will give a reply to the sender, so that the sender starts packets to the receiver. So this is the persistent timer to avoid this waiting time. So deadlock is nothing but a waiting time, mutual waiting time. So here the sender is waiting and receiver is waiting. Okay. Next, the next one is Keepalive Timer. The next one is Keepalive Timer. So this is to identify the dead connection. For example, so here the sender is there and here the receiver is there, and it was keep on messaging, and unfortunately the system crashes. Okay, so this particular source or sender, the sender will be treating that still the connection is alive, but unfortunately the system crashes or the connection disconnected or hang up. Okay, the connection hang up, right? So in such case, this particular Keepalive timer will be on, and if the system is in idle, so if the system is in idle for some time, then immediately sender will send a message to the receiver, and if there is a response, connection is alive, and if there is no response, what happens? It's a dead connection. So once again it should be reconnected. That implies once again it should be reconnected. So this is the use of Keepalive timer in order to check whether there is a dead connection or still the connection is alive. Okay, so mutual, if any one of the device is disconnected, so it have to know that the connection should be re-established. So for that purpose this Keepalive timer will be used. And coming to the fourth one, the last timer, time wait timer. So this time wait timer means it is for proper close. This will be used for closing or terminating the connection properly. So used to terminate connection smoothly. So in our previous session we have seen one state called a time wait state. That means once the server sends the finished message to the client, and the client have to send the acknowledgement, and it moves to the time wait. It never closes immediately. Okay, the connection will not be closed immediately, so it will be wait for some time to receive any delay packets in the network, to avoid the delay packets in the network. So the connection never closes immediately. waits for some time to get delayed packets, to get the delayed packets. So for that, this is a time wait timer. Okay, in order to close or terminate the connection smoothly, right? So these are all different timers that will be used by the TCP protocol. So in order to perform some action, so these are the timers used to before performing any action, the TCP will be taking care. Okay, so hope you understood this one, and I'll stop here. If you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.